this is the Kepler Space Telescope, and you might not think of it as a supernova observatory, but that's exactly what it's done. If you remember, it's actually planet hunting, which is showing what it's doing there, but it stared at a region of sky that we'll see on the next slide. We'll see what region it was staring at, and it looked there for many years, and there's lots and lots of galaxies in that area, and galaxies have stars, and stars sometimes explode as supernovae. So Kepler caught some supernova that went off, and it caught them throughout the entire supernova explosion. So this is special. You don't often get a chance to see that. And it caught something called the breakout as the shock wave of the core of the supermassive star. It's a different kind of supernova, actually. This is a
and
supermassive.
it's an artist.
This is an artist rendering of it,
Yeah.
But what Kepler does is it takes images every 30 minutes, so it has very fine time resolution, so it can see when something starts. Well, there is a phase of a supermassive star, one of these 100-mass stars, that when they explode, the shock wave will work its way from the center of the star out to the surface, and for about a 20-minute period, it'll be extremely bright. We saw that for the first time. It was predicted by theory, and Kepler finally saw it. So we go forward, we can see a little graph that shows what it should be doing. It's nothing there, and then you get a spike. That's that shock wave coming out, the shock breakout. And because Kepler's taking so many images, and they're so short, you're able to actually see that brightness enhancement.
Yeah,
And then
catch it in the
catch
act.
it in the act happening.
Breakout.
Breakout, yes.
Okay, but you
I
already
was
have
waiting
one.
I wanted someone
Did
else
someone
to get
else
it.
say
I
it?
just said.
Okay,
All right.
another prize. Totally, prize.
I kept waiting for someone to do
Yeah.
it. I didn't want to take two.
Why don't you just bring a big bag next time and just take all the stuff about it? Yeah.
So we have a little animation here that shows what Kepler was witnessing. Now all it really saw was the star get brighter. It doesn't see the stars like this. This, again, is an artist's rendering of what happened. So the star down deep in the core, things are happening. The core is getting ready to collapse, and the shock wave works its way out. It sees it. Boom, it sees this flash. Lasts about 20 minutes, and then the debris is expanding. It's very, very hot, and that's why it will get brighter than it did during that shock breakout, because it's so large. It's like having a giant, giant inferno. So it saw this flash breakout. However, it caught two supernovae. It only saw this shock breakout in one of them. Why it didn't see it in the other, we're not sure. It could just be that the other one was shrouded in too much dust and gas, and you couldn't see it. So, but we're waiting to see more. Kepler's still making observations, and its new mode of observing, it could see more supernovae. So,
Very cool. Very hot. Anyway.
but not so young.
But not so young, exactly. Well, actually, it's anyway. I mean, they're that's
Yeah.
the kind of supernova
Yeah.
that those 50 solar mass, those really hot young stars will. That's how they'll
Yeah, when
go.
they live fast, die young. They
Yeah, that's what
die
they
as
do.
supernovae.
Yeah.